This one is June 2019 paper, and this is according to the new specification. How you identify it's new or old? If it is WCH11, it means it is new. If it is WCH01, it means according to old specification. It's not the only difference between the specification is they only shuffle the topics. It's not like any new things added. It's like moving some topics from unit 1 to unit 2 and other way around. So the first question, which statement is not true for sodium chloride? So sodium chloride, it is an ionic compound, and ionic compound, how they exist as a lattice. So sodium chloride conduct electricity in aqueous. That is true because ionic compound, an ionic compound can conduct electricity in aqueous. That is true. Sodium chloride conduct electricity in molten, in a melted state. That's also true. Sodium chloride is a molecular structure. That is wrong because molecular structure means like finite number of atoms or particles in the structure. But ionic compounds, all the ionic compounds, they have a giant structures. So C is a statement which is not true. In question 2, which of these molecule the most polar? So remember, electronegativity increases as we move across the period and it decreases as we go down the group. The most electronegative element in the periodic table is fluorine. So this will be non-polar. We are left with HF, HCl, and HBr, which is a which is having a greater electronegativity. Fluorine is having a greater electronegativity. Means it has a greater tendency to attract the shared pair of electrons. So as a result, because it is having a greater tendency to attract the shared pair of electrons, so these electrons are shifted more towards fluorine. So there will be more partial negative and positive charge appear on hydrogen fluoride as compared to other molecule. That's why B is the right answer. A covalent bonding is best described as electrostatic attraction. Basically, what is a covalent bonding? It is also attraction. What happened, for example, say hydrogen. Hydrogen is having one proton and one electron. This is one atom of hydrogen. Then there will be another atom of hydrogen which will have one proton and one electron. And they will share the electron between, there will be a sharing of electron between the two atoms. And what the electrostatic attraction in terms of covalent bond, in terms of electrostatic attraction is basically, it is the attraction between the nucleus and the electrons. Because nucleus is positively charged and electrons are negative. So a pair of a shared electron and attraction between the nucleus, this is actually a covalent bond. That's why the bond remain intact when the molecules are closer to each other. So oppositely charged in terms of attraction, it is not oppositely charged ion. Oppositely charged ion is for ionic. Positive ion and the delocalized electron, that is for metals, like metallic bonding. A shared pair of electron, it is not attract because shared pair of electron does not attract each other. The shared pair repel. Why the shared pair repel? Because like charges, electron, both are negative, so they tend to repel each other. So it is not attraction between the electron, it is actually the attraction between the two nuclei. Like the nucleus is there, which contain neutrons and protons. That nucleus is attracting the shared pair. So this attraction between the nucleus and the shared pair, we call that as covalent bond. So that's why D is the right answer. Then question 4, which is the correct for tetrafluoromethane? So what is correct for tetrafluoromethane? Look, what about the bonds? whenever bonds are formed between the two elements which are having a difference in the electronegativity, so bonds will be polar. And what about the molecule? Because if the molecule is having symmetry, so overall molecule will be non-polar because overall molecule is having a symmetry. Like all they try to cancel out each other. This is attracting. This is also attracting. This is attracting. So they all try to cancel out each other. As a result, when they cancel out each other, so overall molecule will be non-polar, but because bond is between the two different types of atoms, when two different types of atoms, the bond will be polar, but the molecule, because it's a symmetrical molecule, so molecule will be non-polar. That's why C will be the right answer. Which pair of ions give the strongest ionic bond? To form the strongest ionic bond, number one, the size of the ions should be small as possible, and the charge on the ions should be greater. So these are the two things which decide the strength of ionic bond. When they are isoelectronic except like sodium fluoride, potassium bromide, magnesium oxide, calcium sulfide. So when we check the size, because oxygen -2 means it will have 10 electrons, so it will be 2 and 8, so 2 shells. Sulfur -2, so sulfur is 2 8 16 -2, so it is 2 8 8. So sulfur is larger in size, and when we compare magnesium, magnesium is 12, but it loses 2 electrons, so it will be 2 8. So 2 shells are there in magnesium and 2 shells are there in oxygen, and oxygen is having -2 and magnesium +2, where calcium is 2 8 8. So calcium is +2 and sulfide is -2. So when we check magnesium oxide or calcium sulfide, because magnesium oxide, that is smaller in size, like magnesium is having 2 shells, oxygen is also having 2 shells. So the ions will be closer to each other. As a result, when these ions are closer to each other, they will have a strong attraction. And when they have a strong attraction, the bond will be stronger. That's why magnesium oxide will have a strong ionic bond. In question 6, 1.31 gram of a chloride of titanium, there is 0.52 grams of titanium. What is the empirical formula? So this is a total mass 1.31. The titanium is 0.528. So we will subtract to get the mass of, so 1.31 minus 0.528. That will give us 0.728. So mass of a chlorine is equal to 782, sorry. And mass of titanium, that is given 0.528. Then divide by atomic mass, 47.9 and 35.5. So 0.528 divided by 47.9. And this one is 0.02. Then divide by smallest value. So we'll divide by the smallest value in the combination. So we'll divide by 0.011 and 0.011. So this will be 1 and this will be 2. So the empirical formula of this compound is TiCl2. So B will be the right answer. So divide by atomic mass, then divide by smallest value and round off to the nearest whole number. Simplify the like the simplest ratio should be in a whole number. Which isotope is used as a standard definition of relative atomic mass? Relative atomic mass is a mass of atom, average mass of atom, which is compared with carbon 12. So that's why B is the right answer. So it's direct question, straightforward question. You have to learn the definition of relative atomic mass. You will find in exam, they ask this question that define relative atomic mass. Then which statement about subatomic particle is correct? So in the question, a neutral atom always contains the same number of proton and electron. That is true. So A is the right answer. Why not B? A neutral atom contains same number of proton and neutron. That is wrong. Electrons have a relative mass of 1. They don't have relative mass of 1. That is 1 divided by 1840. And proton has a relative mass of 1 and no charge. This is correct. But charge is there. It is relative charge is +1. So A is the right statement. Which sketch graph shows the trend in ionization energy value going down the group? So as we go down the group, the size increases. So if the size increases, the ionization energy should decrease. So which one shows, which trend shows that as we go down the group, the size is increasing, so ionization energy should decrease. So either A can be an answer, C, but C is not showing a proportion here. Like C shows that it first initially it is changing small and then greater change, but it is opposite, because initially there is a greater change and then it is approximately constant. That's why A is the right answer. This trend is there across the period, and this is there down the group. In question 10, isotopes are atoms of an element that have different. So they have different number of neutrons. So D is the right answer. Atoms of the same element contain same number of proton but different number of neutrons. Then two stable isotopes of a bromine have a relative mass of 79 and 81. What is the correct pattern of the peaks? How to identify? Remember, look, 79 is 50%. So you may have bromine 79, which is 50%. We may have bromine 81, which is also 50%. But we might get a bromine molecule. So if we might get a bromine molecule, possibility is there. First atom might be 79 and second atom might be 81. So we will get peak at 160 because 79 plus 81, 160, and that is 50%. And what about the second one? This will be bromine. Maybe the first atom is 81 and the second atom is 79. So that we'll get a peak at 160, and that is also 50%. So means when we work out 50% this, 50% this, and 100%. So this is 50%. This one will be 100%, or this will be 50. So the ratio will be 1 to 1. Means like if we have bromine 79, it will be like 1 centimeter. If we have bromine 81, that will be 1. And if we have bromine molecule, that should be twice the height. So we have to check. And the second possibility, how many peaks per molecule will be there? Like this is, so maybe the two atoms which are there in the molecule, maybe both of them are 79. So if both of them are 79, we'll get a peak at 158. And that is, this total is 100, this will be 50%. And here, if we get bromine 81, both of them are 81, so we'll get a peak at 162. So that is also 50%. So 100% is there for bromine. When two things are there, like bromine molecule peaks can be for 158, it can be for 160, it can be for 162. So that if it is 158, it will be like 1, 2, 1, or you can say 50% or 100% or 50%. So this is always 1-to-1 ratio will be there. So 1/6, we'll check the options in which. So you can see D, two of the peaks 79 and 81 are equal amount. But when we compare 158 and 162, they are half of 160. So that's why D is the right answer. And same thing you have to learn for chlorine as well, because it can happen for chlorine. So in that case, it is 9, 3, and 1. When a mass spectrum of a sample of a silicon is there, what is the best estimated? Look, here no scale is mentioned. Relative abundance scale is not there. If relative abundance scale is not there, you can use your ruler, you can use your scale to work out the percentage. Like using your ruler or a scale, you will place here, you will measure this length. I'm just giving an example, like say this is say 10 centimeter. This is 1 centimeter. This is also 1 centimeter. So what we will do, like if this is 10 centimeter, example, this is just an example, 1 centimeter and 1. So this will be 10 into 28 plus 1 into 29 plus 1 into 30 and divided by total 10 plus 1 plus 1. So that is 12. And it is obvious that because 28, 29 and 30, so what will be the likely position we'll get a peak? Without even calculation, I can tell, because 28 is more than, if it was like example 28 and 30 were in equal amount, then the answer will be 29 because average will be 29. But here 28 is more and 30 is less. So the average won't be 29, average will be more towards 28. So which one is the average? This is like near 29, it cannot be or 29. So either A or it cannot be A, because if it was only 28, then A will be the answer. So that's why B is the right answer. So you can use a ruler scale, measure the length and work out the relative atomic mass, or you can also use your understanding of the average. If two values are equal, then the average will be the number in between them. But if two values are not equal, one is having a higher percentage abundance than other, so average will be more towards 28. And the same thing is the same question, but the 30 was more than 28. The 30 was more than 28, so then the percentage abundance will be closer to 30. Which is the equation for a second ionization energy. Second ionization energy means energy needed to remove the second electron from an atom. So first is, and from a gaseous state. So the charge should be +2. So this is wrong. Why this is wrong? Because we are removing 2 electrons. One is already removed and we are removing the second. So that's called a second ionization. So B is the right answer. C is third ionization and D is wrong, because energy needed to remove 1 electron from a gaseous state, that is refers to ionization. The bar chart shows the melting point of first 20 elements. So the bar chart showed the melting temperature. So how to identify, like as you can see, this bar chart is there, that is representing the first 20 elements. The giant covalent structure has the highest in period 2. That is true, because remember, like this is group 1, then group 2, then group 3, then group 4, the giant covalent, then group 5, 6, 7, and 8. And then this is period 1, because hydrogen and helium period 1, and then this is from 3 to 10, that is period 2, second period, and then from 11. So group 1 again, group 2, group 3, group 4, group 5, group 6, group 7, and group 8. So till here, third period. So you can see group 4 elements occupy the highest because they have giant structures. So a giant covalent structure are the highest in period 2 and period 3. So that's why A is the right answer. In question 15, which is electronic configuration for scandium? So for scandium, you have to check scandium plus 3 ion. So you have to check the periodic table. Scandium is 21. Remember, whenever you have a D block element, first write the electronic configuration and then remove the electron, not directly. So first I will write the scandium electronic configuration for 21 electrons. So 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. So 20 are there, and then 3d1. Now when we remove this is in terms of energy, but it should be in order. So 1s2 should be there, then 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. So when we remove the electron, 2 electron removed from here and 1 electron removed from here. So we remove first electron will be removed from 4s, then 4s, and then 3d. So this is what we are left with when we remove 3 electron. So 1s2, 2s2, 2p6, 3s2, and 3p6. So that A will be the right answer. So remember, whenever for transition element you are removing the electron, first write the configuration, then arrange them in order, and then remove the electron. After that, remove the electron from the last shell. What is the name of a product when its molecule react with chlorine? So when molecule react with chlorine, this double bond will break because addition reaction occur. So this bond here will break. And there will be 2 chlorine attached. Now when 2 chlorine are attached, now we'll start a numbering. Numbering should start from a nearest branch or a functional group. So here 1, 2, 3, 4, and 5. This is a branch. So which position? 1, 2, 3, 4th position we have a methyl group, and first and second position we have chlorine. So it is 1, 2 dichloro, because 1, 2 dichloro, 2 chlorine are there, and 4 methyl, because 4th position we have a methyl group, that is a branch. And why pentane? Because there are 1, 2, 3, 4, 5 carbons, so it is pentane, or D is the right answer. So it is 1, 2 dichloro, 4 methyl, pentane. What type of bond breaking occur in this process? So it is two types of bond breaking are there, either homolytic or heterolytic. Homolytic means like different, and heterolytic means different, and homolytic means same. Like it produce radical, and this produce charges plus and minus. So you can see when the bond break, it produce positive and negative ions. So that's why it is a heterolytic bond breaking. So only 2 types of bond breaking are there. Homolytic will produce free radical, and heterolytic produce positive and negative ions. In question 18, what reagent and conditions are used to convert? So we want to convert alkene into alcohol, so we need steam, and we use phosphoric acid as a catalyst. So C is the right answer, because double bond break here, and one side OH, another side H is added. So, and if we want to convert into diol, then potassium manganate 7 should be used. Butene shows a geometrical isomer. What prefixes can be used? You have to check the heavy group. The heavy groups are on the same side. So if the heavy groups are on the same side, so we call that as a cis or Z. So cis or Z, so B will be the right answer. Like we compare here CH3 with H and we compare CH3 with H. So both the heavy groups are on the same side. What is the major product of this? So when addition reaction occur, the two products will be there. One is a major, another one is a minor. Major product, the hydrogen will be added towards side where hydrogen are already more. So here, this contain two hydrogen, the left hand side carbon and the right hand side carbon contain one hydrogen. So major product, hydrogen added towards side where already hydrogen are more. So hydrogen will be added here. The double bond will break. CH2, CH3, and then H and Br. And what will the minor product? The minor product will be H, Br, CH2, CH3, and H will be there. So this will be the minor product. So we have to check which one shows the major product, the product which can be formed. So bromine will be attached. Like here CH3 will be there because in terms of structure, so this is CH3, this is CH3, and then this CH. So this is CH3, this is CH3, and then this CH is there and Br is there, and then CH2, this is CH2, and then CH3. So A is the right answer. So major product is the one in which hydrogen added towards side where already hydrogen are more, and minor will be opposite. So A will be the right answer for this. So this was June 2019 paper.